Preface. Welcome to College Physics for AP Courses 2E, an OpenStax resource. This textbook was written to increase student access to high-quality learning materials, maintaining highest standards of academic rigor at little to no cost. About OpenStax. OpenStax is a part of Rice University, which is a 501(c)(3) nonprofit charitable corporation. As an educational initiative, it is our mission to transform learning so that education works for every student. Through our partnerships with philanthropic foundations and our alliance with other educational resource organizations, we're breaking down the most common barriers to learning, because we believe that everyone should and can have access to knowledge. About OpenStax resources. Customization. College Physics for AP Courses 2E is licensed under a Creative Commons Attribution 4.0 International (CC BY) license, which means that you can distribute, remix, and build upon the content, as long as you provide attribution to OpenStax and its content contributors. Because our books are openly licensed, you are free to use the entire book or select only the sections that are most relevant to the needs of your course. Feel free to remix the content by assigning your students certain chapters and sections in your syllabus, in the order that you prefer. You can even provide a direct link in your syllabus to the sections in the web view of your book. Instructors also have the option of creating a customized version of their OpenStax book. The custom version can be made available to students in low-cost print or digital form through their campus bookstore. Visit the Instructor Resources section of your book page on openstax.org for more information. Art attribution. In College Physics for AP Courses 2E, most photos and third-party illustrations contain attribution to their creator, rights holder, host platform, and/or license within the caption. Because the art is openly licensed, anyone may reuse the art as long as they provide the same attribution to its original source. To maximize readability and content flow, some art does not include attribution in the text. This art is part of the public domain or under a CC0 or similar license, and can be reused without attribution. For illustrations, e.g., graphs, charts, etc., that are not credited, use the following attribution. Copyright Rice University, OpenStax, under CC BY 4.0 license. Errata. All OpenStax textbooks undergo a rigorous review process. However, like any professional-grade textbook, errors sometimes occur. Since our books are web-based, we can make updates periodically when deemed pedagogically necessary. If you have a correction to suggest, submit it through the link on your book page on openstax.org. Subject matter experts review all errata suggestions. OpenStax is committed to remaining transparent about all updates, so you will also find a list of past errata changes on your book page on openstax.org. Format. You can access this textbook for free in WebView or PDF through openstax.org, and for a low cost in print. About College Physics for AP Courses 2E. College Physics for AP Courses 2E is designed to engage students in their exploration of physics and help them apply these concepts to the advanced placement test. Because physics is integral to modern technology and other sciences, the book also includes content that goes beyond the scope of the AP course to further student understanding. The AP connection in each chapter directs students to the material they should focus on for the AP exam, and what content, although interesting, is not necessarily part of the AP curriculum. This book is Learning List approved for AP Physics courses. This content features enhancements from TAP Physics 1 and 2, algebra based by Texas Education Agency. Coverage, scope, and alignment to the AP curriculum. The current AP Physics curriculum framework outlines the two full-year physics courses AP Physics 1, algebra-based, and AP Physics 2, algebra-based. These two courses replaced the one-year AP Physics B course, which over the years had become a fast-paced survey of physics facts and formulas that did not provide in-depth conceptual understanding of major physics ideas and the connections between them. AP Physics 1 and 2 courses focus on the big ideas typically included in the first and second semesters of an algebra-based, introductory college-level physics course, providing students with the essential knowledge and skills required to support future advanced coursework in physics. The AP Physics 1 curriculum includes mechanics, mechanical waves, sound, and electrostatics. The AP Physics 2 curriculum focuses on thermodynamics, fluid statics, dynamics, electromagnetism, geometric and physical optics, quantum physics, atomic physics, and nuclear physics. 7 unifying themes of physics called the Big Ideas each include 3 to 7 enduring understandings, EU, which are themselves composed of essential knowledge, EK, that provides details and context for students as they explore physics. AP Science practices emphasize inquiry-based learning and development of critical thinking and reasoning skills. Inquiry usually uses a series of steps to gain new knowledge, beginning with an observation and following with a hypothesis to explain the observation. Then experiments are conducted to test the hypothesis, gather results, and draw conclusions from data. The AP framework has identified 7 major science practices, which can be described by short phrases. Using representations and models to communicate information and solve problems. Using mathematics appropriately. Engaging in questioning, planning and implementing data collection strategies. Analyzing and evaluating data. Justifying scientific explanations, and connecting concepts. The framework's learning objectives merge content, EU and EK, with one or more of the 7 science practices that students should develop as they prepare for the AP Physics exam. College Physics for AP Courses 2E is based on the OpenStax College Physics text, adapted to focus on the AP curriculum's concepts and practices. Each chapter of OpenStax College Physics for AP Courses 2E begins with a connection for AP Courses Introduction that explains how the content in the chapter sections align to the big ideas, enduring understandings, and essential knowledge in the AP framework. This textbook contains a wealth of information, and the connection for AP Courses sections will help you distill the required AP content from material that, although interesting, exceeds the scope of an introductory level course. Each section opens with the program's learning objectives as well as the AP learning objectives and science practices addressed. We have also developed real-world connections features and applying the science practices features that highlight concepts, examples, and practices in the framework. 1. Introduction. The nature of science and physics. 2. Kinematics. 3. Two-dimensional kinematics. 4. Dynamics. Force and Newton's laws of motion. 5. Further applications of Newton's laws, friction, drag, and elasticity. 6. Gravitation and uniform circular motion. 7. Work, energy, and energy resources. 8. Linear momentum and collisions. 9. Statics and torque. 10. Rotational motion and angular momentum. 11. Fluid statics. 12. Fluid dynamics and its biological and medical applications. 13. Temperature, kinetic theory, and the gas laws. 14. Heat and heat transfer methods. 15. Thermodynamics. 16. Oscillatory motion and waves. 17. Physics of hearing. 18. Electric charge and electric field. 19. Electric potential and electric field. 20. Electric current, resistance, and Ohm's law. 21. Circuits, bioelectricity, and DC instruments. 22. Magnetism. 23. Electromagnetic induction, AC circuits, and electrical technologies. 24. Electromagnetic waves. 25. Geometric optics. 26. Vision and optical instruments. 27. Wave optics. 28. Special relativity. 29. Introduction to quantum physics. 30. Atomic physics. 31. Radioactivity and nuclear physics. 32. Medical applications of nuclear physics. 33. Particle physics. 34. Frontiers of physics. Appendix A. Atomic masses. Appendix B. Selected radioactive isotopes. Appendix C. Useful information. Appendix D. Glossary of key symbols and notation. Pedagogical foundation and features. College Physics for AP Courses 2E is organized so that topics are introduced conceptually with a steady progression to precise definitions and analytical applications. The analytical, problem-solving aspect is tied back to the conceptual before moving on to another topic. Each introductory chapter, for example, opens with an engaging photograph relevant to the subject of the chapter and interesting applications that are easy for most students to visualize. 1. Connections for AP courses introduce each chapter and explain how its content addresses the AP curriculum. 2. Worked examples. Examples start with problems based on real-life situations, then describe a strategy for solving the problem that emphasizes key concepts. The subsequent detailed mathematical solution also includes a follow-up discussion. 3. Problem-solving strategies are presented independently and subsequently appear at crucial points in the text where students can benefit most from them. 4. Misconception alerts address common misconceptions that students may bring to class. 5. Take-home investigations provide the opportunity for students to apply or explore what they have learned with a hands-on activity. 6. Real-world connections highlight important concepts and examples in the AP framework. 7. Applying the science practices includes activities and challenging questions that engage students while they apply the AP science practices. 8. Things great and small explains macroscopic phenomena, such as air pressure, with submicroscopic phenomena, such as atoms bouncing off of walls. 9. PhET explorations link students to interactive PhET physics simulations, developed by the University of Colorado, to help them further explore the physics concepts they have learned about in their book module. Assessment. College Physics for AP Courses 2E offers a wealth of assessment options, including the following end-of-module problems. 1. Integrated concept problems challenge students to apply both conceptual knowledge and skills to solve a problem. 2. Unreasonable results encourage students to solve a problem and then evaluate why the premise or answer to the problem are unrealistic. 3. Construct your own problem requires students to construct how to solve a particular problem, justify their starting assumptions, show their steps to find the solution to the problem, and finally discuss the meaning of the result. 4. Test prep for AP courses includes assessment items with the format and rigor found in the AP exam to help prepare students for the exam. AP Physics Collection. College Physics for AP Courses 2E is a part of the AP Physics Collection. The AP Physics Collection is a free, turnkey solution for your AP Physics course, brought to you through a collaboration between OpenStax and Rice Online Learning. The integrated collection pairs the OpenStax College Physics for AP Courses text with concept trailer videos, instructional videos, problem solution videos, and a correlation guide to help you align all of your content. The instructional videos and problem solution videos were developed by Rice professor Jason Hafner and AP Physics teachers Gigi Nevels-Noe and Matt Wilson through Rice Online Learning. You can access all of this free material through the College Physics for AP Courses 2E page on openstax.org. Changes to the second edition. College Physics for AP Courses 2E builds on the first edition's guiding principle that physics is a discipline undertaken by and for people. Throughout the text, the human impact of physics understanding, phenomena, discoveries, and applications is made clear through widespread examples, scenarios, and explanations. The narrative of physics and scientific discovery has been even further expanded to focus on including more diverse contributors to the field. From Ibn al-Haytham's 11th century foundation of the scientific method to Gladys West's complex models enabling GPS, the second edition broadens the discussion of pioneering and current researchers in an effort to tell a more accurate and inclusive scientific and societal story. Relevance and responsiveness. The impact of physics on engineering, urban development, the environment, medicine, energy production, and other aspects of everyday life have been updated and expanded to reflect more student experiences and interests. Techniques and developments in related disciplines are covered in context, not only in opening vignettes, so that students encounter the deep impact of evolving knowledge relevant to their potential fields of study. Since many introductory physics students are focused on medicine, sections and examples related to biology have been significantly expanded. The section on electric forces in biology, 18.6, for example, has been deepened to include Ernest Everett Just's work on electronegativity in ova, as well as the emerging practice of electrical stimulation in wound healing. Additional biological application narratives include Yalow and Berson's development of radioimmunoassay, and Strickland and Maru's invention of chirped lasers used in vision correction. Currency and accuracy. We have updated sections related to ongoing research, frontiers of physics, and emerging information. In particular, Section 4.8 on the 4 basic forces has been revised with information about recent discoveries and ongoing research, as well as with additional context about the ongoing process of discovery. For example, the progression from Einstein's black hole predictions to the first black hole images produced in 2019. The section on world energy use, 7.9, the section on ozone depletion, 24.3, and several sections discussing space telescopes have been similarly updated to reflect current research and data. Over 10 years of widespread usage, OpenStax College Physics has benefited from suggestions, corrections, and clarifications submitted by hundreds of faculty and also from students. We have made the requisite corrections and improvements over time, but the second edition unifies those edits for more consistency and ease of use. Improving problem solving and deepening understanding. College Physics for AP Courses 2E employs the best practices of physics teaching, informed by education research and extensive adopter feedback. In order to unify conceptual, analytical, and calculation skills within the learning process, the authors have integrated a wide array of strategies and supports throughout the text. Worked examples. Worked examples have 4 distinct parts to promote both analytical and conceptual skills. Worked examples are introduced in words, always using some application that should be of interest. This is followed by a strategy section that emphasizes the concepts involved and how solving the problem relates to those concepts. This is followed by the mathematical solution and discussion. Many worked examples contain multiple part problems to help the students learn how to approach normal situations, in which problems tend to have multiple parts. Finally, worked examples employ the techniques of the problem-solving strategies so that students can see how those strategies succeed in practice as well as in theory. About the authors. Senior contributing authors: Irina Lublinskaya, CUNY College of Staten Island; Greg Wolfe, Avonworth High School; Douglas Ingram, Trinity Christian University; Liza Puji, Manuko Institute of Technology, New Zealand; Sudhi Oberoi, visiting research student, Quick Lab, Raman Research Institute, India; Nathan Shuba, Sabio Academy; Julie Kretschmann, science writer, B.S., University of Toronto; John Stoke, science writer, M.S., University of Chicago; David Anderson, science writer, Ph.D., College of William and Mary; Erica Gasper, science writer, M.A., University of California, Santa Cruz; Kenneth Podolak, State University of New York, Plattsburgh; Henry Smith, River Parishes Community College. Advanced Placement Teacher Reviewers: John Boringer, Prosper High School; Victor Brazil, Petaluma High School; Michelle Burgess, Avon Lake High School; Brian Callow, Lindenwold High School; Brian Hastings, Spring Grove Area School District; Alexander Lavie, Xavier High School; Jerome Mass, Glastonbury Public Schools. Faculty Reviewers: John Aiken, Georgia Institute of Technology; Robert Arts, University of Pikeville; Anand Batra, Howard University; Michael Ottinger, Missouri Western State University; James Smith, Caldwell University; Ulrich Zerker, Cleveland State University. Additional resources. Student and instructor resources. We've compiled additional resources for both students and instructors, including Getting Started guides, an instructor's manual, test bank, and image slides. Instructor resources require a verified instructor account, which you can apply for when you log in or create your account on openstax.org. Take advantage of these resources to supplement your OpenStax book. 1. Instructor Solutions Manual. The Instructor Solutions Manual contains the instructor-facing answers to the problems and exercises within the textbook. Since many instructors use these questions in graded assignments, we ask that you not post these questions and the answers on any publicly available websites. 2. PowerPoint Lecture Slides. The PowerPoint slides provide images and descriptions as a starting place for instructors to build their lectures. 3. Concept Trailer Instructor Notes. These teaching notes support implementation of the OpenStax physics concept trailers. The notes contain tips for usage, clarifications of coverage, and guidance on how to use the trailers in different educational situations. Academic Integrity. Academic integrity builds trust, understanding, equity, and genuine learning. While students may encounter significant challenges in their courses and their lives, doing their own work and maintaining a high degree of authenticity will result in meaningful outcomes that will extend far beyond their college career. Faculty, administrators, resource providers, and students can work together to maintain a fair and positive experience. We realize that students benefit when academic integrity ground rules are established early in the course. To that end, OpenStax has created an interactive to aid with academic integrity discussions in your course. 1. Approved, your original work, quoting and crediting another's work. 2. Ask instructor, checking your answers online, group work, reusing past original work, sharing answers. 3. Not approved, getting others to do your work, posting questions and answers, plagiarizing work. Visit our academic integrity slider, https://view.genial.ly/61E0887F6DB870D591078C1/interactive-image-defining-academic-integrity-interactive slider. Click and drag icons along the continuum to align these practices with your institution and course policies. You may then include the graphic on your syllabus, present it in your first course meeting, or create a handout for students. At OpenStax, we are also developing resources supporting authentic learning experiences and assessment. Please visit this book's page for updates. For an in-depth review of academic integrity strategies, we highly recommend visiting the International Center of Academic Integrity, ICAI, website at https://academicintegrity.org/ https://academicintegrity.org/. Community Hubs. OpenStax partners with the Institute for the Study of Knowledge Management in Education, ISKME, to offer community hubs on OER Commons, a platform for instructors to share community-created resources that support OpenStax books, free of charge. Through our community hubs, instructors can upload their own materials or download resources to use in their own courses, including additional ancillaries, teaching material, multimedia, and relevant course content. We encourage instructors to join the hubs for the subjects most relevant to your teaching and research as an opportunity both to enrich your courses and to engage with other faculty. To reach the community hubs, visit www.urcommons.org/hubs/OpenStax. https://www.urcommons.org/hubs/OpenStax. Technology partners. As allies in making high-quality learning materials accessible, our technology partners offer optional low-cost tools that are integrated with OpenStax books. To access the technology options for your text, visit your book page on openstax.org. To the AP Physics student. The fundamental goal of physics is to discover and understand the laws that govern observed phenomena in the world around us. Why study physics? If you plan to become a physicist, the answer is obvious. Introductory physics provides the foundation for your career. Or if you want to become an engineer, physics provides the basis for the engineering principles used to solve applied and practical problems. For example, after the discovery of the photoelectric effect by physicists, engineers developed photocells that are used in solar panels to convert sunlight to electricity. What if you are an aspiring medical doctor? Although the applications of the laws of physics may not be obvious, their understanding is tremendously valuable. Physics is involved in medical diagnostics, such as X-rays, magnetic resonance imaging, MRI, and ultrasonic blood flow measurements. Medical therapy sometimes directly involves physics. Cancer radiotherapy uses ionizing radiation. What if you are planning a non-science career? Learning physics provides you with a well-rounded education and the ability to make important decisions, such as evaluating the pros and cons of energy production sources or voting on decisions about nuclear waste disposal. This AP Physics 1 course begins with kinematics, the study of motion without considering its causes. Motion is everywhere, from the vibration of atoms to the planetary revolutions around the sun. Understanding motion is key to understanding other concepts in physics. You will then study dynamics, which considers the forces that affect the motion of moving objects and systems. Newton's laws of motion are the foundation of dynamics. These laws provide an example of the breadth and simplicity of the principles under which nature functions. One of the most remarkable simplifications in physics is that only 4 distinct forces account for all known phenomena. Your journey will continue as you learn about energy. Energy plays an essential role both in everyday events and in scientific phenomena. You can likely name many forms of energy, from that provided by our foods, to the energy we use to run our cars, to the sunlight that warms us on the beach. The next stop is learning about oscillatory motion and waves. All oscillations involve force and energy. You push a child in a swing to get the motion started, and you put energy into a guitar string when you pluck it. Some oscillations create waves. For example, a guitar creates sound waves. You will conclude this first physics course with the study of static electricity and electric currents. Many of the characteristics of static electricity can be explored by rubbing things together. Rubbing creates the spark you get from walking across a wool carpet, for example. Similarly, lightning results from air movements under certain weather conditions. In the AP Physics 2 course, you will continue your journey by studying fluid dynamics, which explains why rising smoke curls and twists and how the body regulates blood flow. The next stop is thermodynamics, the study of heat transfer, energy in transit, that can be used to do work. Basic physical laws govern how heat transfers and its efficiency. Then you will learn more about electric phenomena as you delve into electromagnetism. An electric current produces a magnetic field. Similarly, a magnetic field produces a current. This phenomenon, known as magnetic induction, is essential to our technological society. The generators in cars and nuclear plants use magnetism to generate a current. Other devices that use magnetism to induce currents include pickup coils in electric guitars, transformers of every size, certain microphones, airport security gates, and damping mechanisms on sensitive chemical balances. From electromagnetism you will continue your journey to optics, the study of light. You already know that visible light is the type of electromagnetic waves to which our eyes respond. Through vision, light can evoke deep emotions, such as when we view a magnificent sunset or glimpse a rainbow breaking through the clouds. Optics is concerned with the generation and propagation of light. The quantum mechanics, atomic physics, and nuclear physics are at the end of your journey. These areas of physics have been developed at the end of the 19th and early 20th centuries and deal with submicroscopic objects. Because these objects are smaller than we can observe directly with our senses and generally must be observed with the aid of instruments, parts of these physics areas may seem foreign and bizarre to you at first. However, we have experimentally confirmed most of the ideas in these areas of physics. AP Physics is a challenging course. After all, you are taking physics at the introductory college level. You will discover that some concepts are more difficult to understand than others. Most students, for example, struggle to understand rotational motion and angular momentum or particle wave duality. The AP curriculum promotes depth of understanding over breadth of content, and to make your exploration of topics more manageable, concepts are organized around 7 major themes called the big ideas that apply to all levels of physical systems and interactions between them. See web diagram below. Each big idea identifies enduring understandings, EU, essential knowledge, EK, and illustrative examples that support key concepts and content. Simple descriptions define the focus of each big idea. Big Idea 1. Objects and systems have properties. Big Idea 2. Fields explain interactions. Big Idea 3. The interactions are described by forces. Big Idea 4. Interactions result in changes. Big Idea 5. Changes are constrained by conservation laws. Big Idea 6. Waves can transfer energy and momentum. Big Idea 7. The mathematics of probability can to describe the behavior of complex and quantum mechanical systems. Doing college work is not easy, but completion of AP classes is a reliable predictor of college success and prepares you for subsequent courses. The more you engage in the subject, the easier your journey through the curriculum will be. Bring your enthusiasm to class every day along with your notebook, pencil, and calculator. Prepare for class the day before and review concepts daily. Form a peer study group and ask your teacher for extra help if necessary. The AP Lab program focuses on more open-ended, student-directed, and inquiry-based lab investigations designed to make you think, ask questions, and analyze data like scientists. You will develop critical thinking and reasoning skills and apply different means of communicating information. By the time you sit for the AP exam in May, you will be fluent in the language of physics, because you have been doing real science. you will be ready to show what you have learned. Along the way, you will find the study of the world around us to be one of the most relevant and enjoyable experiences of your high school career. Irina Lublinskaya, Ph.D., Professor of Science Education. To the AP Physics teacher. The AP curriculum was designed to allow instructors flexibility in their approach to teaching the physics courses. College Physics for AP Courses 2E helps you orient students as they delve deeper into the world of physics. Each chapter includes a connection for AP Courses introduction that describes the AP Physics big ideas, enduring understandings, and essential knowledge addressed in that chapter. Each section starts with specific AP learning objectives and includes essential concepts, illustrative examples, and science practices, along with suggestions for applying the learning objectives through take-home experiments, virtual lab investigations, and activities and questions for preparation and review. At the end of each section, students will find the test prep for AP courses with multiple choice and open response questions addressing AP learning objectives to help them prepare for the AP exam. College Physics for AP Courses 2E has been written to engage students in their exploration of physics and help them relate what they learn in the classroom to their lives outside of it. Physics underlies much of what is happening today in other sciences and in technology. Thus, the book content includes interesting facts and ideas that go beyond the scope of the AP course. The AP connection in each chapter directs students to the material they should focus on for the AP exam, and what content, although interesting, is not part of the AP curriculum. Physics is a beautiful and fascinating science. It is in your hands to engage and inspire your students to dive into an amazing world of physics, so they can enjoy it beyond just preparation for the AP exam. Irina Lublinskaya, Ph.D., Professor of Science Education.